Alright, 2.3, let's continue on here. Next one is 58. 58 says we have f of x equals x to the third minus 3x squared plus 5, and we have the point minus 1, 3, and the directions say use a graphing utility to graph this function over the indicated interval. So this is not a point, this is an interval from minus 1 to 3. And then see if we have any local max or mins and then where is it increasing or decreasing, and round to 2 decimal places. So we'll pull out our graphing utility, go to y equals, clear, we'll turn the plot off. Come down, we got x to the third minus 3x squared plus 5, zoom 6, and we're supposed to look for local maximum values and local min. It looks like we have a max right about 0. To check for that, we go second, calculate a maximum, and we're looking somewhere between minus 1 and 1, between negative 1, enter, and 1, enter. We think it's about 0, so I press 0 for my guess, enter, and it says at 0 it's 5, and that's the local max. Of 5 at x equals 0. Looks like we have a local min at about 2. Let's find out. So second, calculate the minimum between, we think it's at 2, so it's between 1 and 3, and we think it's about 2, so that's my guess. And it says, yes, at 2, it's at a minimum. We have a local min of 1 at x equal 2. And let's see, where is the function increasing? Well, it looks like it's increasing all the way up to 0 for all the x's. Negative infinity up to 0, it's increasing. I'm increasing on the interval from negative infinity up to 0 on the x's. Then it decreases, and then it starts increasing starting at 2. From 2 to infinity it's increasing, and it decreases on the interval from x equals 0 to x equal 2, the function decreases. So from 0 to 2, these are the x values for where the function is going up and down. Up or down, increasing or decreasing. That's 58. Then we're supposed to do 65. And 65 says find the average rate of change of f of x equals negative 2x squared plus 4 from 0 to 2. So we put in 0 and we get 4. We put in 2 and we get 4. Negative 8 plus 4 is negative 4. So we put in 2 and we get negative 4. Average rate of change is just what's the slope that you have to use to get from one to the other. So we're just going to calculate the slope now. So y2 minus y1 over x2 minus x1 is negative 8 over 2, which is negative 4. That's the average rate of change. It's going down 4 units for every one across. How about from 0 to The next it said from 1 to 3. So now we'll put in 1. That's minus 2 plus 4 is 2. We'll put in 3. 9, negative 18 plus 4 is negative 14. And the slope is negative 14 minus 2, negative 16. 3 minus 1, 2, which is negative 8. The average rate of change. And finally from 1 to 4. We know when we put in 1, we get 1, 2. When we put in 4, square root of 16 minus 32 plus 4 is minus 28 when we put in 4. So from that point on the function to that point in the function, the average rate of change, the slope, is 28 minus 2. Minus 28 minus 2 is minus 30 over 4 minus 1, 3, which is negative 10. So this thing is getting steeper and steeper and steeper as we look out. Well, let's make some more sense out of this by let's graph this. This is a parabola that's flipped over the x-axis and stretched by a factor of 2. So flipped over the x and stretched by a factor of 2 makes it go 1 minus 2, 2 minus 8. 1 minus 2, 2 minus 8. And then if we go move it up 4, that's where it's actually at. And so 1 over is at down 2 from there, and then down 8, which should put us down 4 below. So this is kind of what it looks like. And the slope from 0 to 4, 3, 4, is going to be pretty steep, going down, negative 4. From 0 to 2, excuse me, 0 to 2, it goes from 4 high to negative 4. So that's the slope of that first interval. That's kind of the average rate of change. From 1 to 3 is even steeper, and from 1 to 4 is going to be even steeper and negative. And that's what these numbers are talking about. So it's getting steeper and steeper going down. Okay? And finally, we got to do 71. And 71 do the same kind of stuff for g of x equals x squared minus 2. We want to go from negative 2 to 1. This is a right side up parabola, move down 2. So from negative 2 to 1 is probably going to be going a negative slope. Let's see if we get that. So if we put in negative, this is the interval. So we got to find the point at negative 2. Squared is 4 minus 2 is 2. We put in negative 2 and got 2. Now we're going to put in 1, and we get 1 minus 2 is minus 1. So it goes from a height of 2 to the height of negative 1 as we go this way. So it goes from 2 to minus 1 is down 3, as x goes from minus 2 to 1, which is plus 3. So we have a negative 1 slope. That's part A. Part B, find the equation of the secant line containing negative 2, g of negative 2, which was 2, and 1 g of that. So we just want the line that goes to these 2 points. Slope is minus 1, so we could write it in point slope or slope intercept. It's y equals negative 1 x plus, and if we put in 1, we get negative 1, and that's what we're supposed to get, so it's plus 0. If you put in negative 2, we get 2 plus what is 2, and that would be 0. So there's the equation in slope-intercept form. You could write it as y minus 2 equals m negative 1 times x minus, we use the 2, so that's minus 2 plus 2. There's the point slope form.